Asteroid strikes, gamma-ray bursts, supernovae blasts, and other terrifying threats could potentially take out humanity. But one of them is inescapable, a cataclysmic event that will happen around 1 billion years from now and most likely rob our planet of its oxygen, effectively wiping out all life forms. Nearly 2.5 billion years ago, there was a period called the Great Oxidation Event. It gave us a breathable atmosphere, thanks to which we're all alive today. Cyanobacteria, also known as blue-green algae, appeared on Earth, filling the atmosphere with oxygen. It eventually led to the appearance of a world filled with multicellular life forms. But then, one of Earth's greatest die-offs occurred. It happened 450 million years ago. This event is known as the Late Ordovician Mass Extinction. Scientists think it might have happened because the inverse process took place. The level of oxygen on the planet dropped dramatically, and it lasted for several millions of years. It's unclear what could have caused such an extreme event. During this period, the continents formed one jumbled mass called Gondwana. Most life on Earth lived in the oceans, but plants were starting to colonize land. Near the end of the Ordovician period, a climate shift covered the supercontinent with glaciers. This dramatic cooling alone was enough to lead a lot of species to the brink of extinction. And then, oxygen levels plummeted, which caused the second wave of extinction. Scientists have found evidence of this event in seafloor samples gathered from all over the world. Some are sure that glaciers were responsible for changing the layers of the oceans, which had previously had unique temperatures and specific concentrations of elements like oxygen. However, the exact cause of the oxygen drop is still unclear. Whatever the cause, more than 80% of life on Earth disappeared during the late Ordovician mass extinction. Could a deoxygenation event happen again? Some researchers draw an eerie comparison to today's situation. They say that climate change is already reducing oxygen levels in our oceans. It's likely to make loads of species go extinct and the world to change beyond recognition. Now, even if global cooling triggered the late Ordovician mass extinction, what sparked this process in the first place? There's a theory claiming it could have been a gamma-ray burst. These bursts seem to be the most violent and energetic explosions in space, and they might be related to supernovae. Thankfully, we haven't seen such a burst close enough to fully figure out what it is. So far, they have only been spotted in other galaxies. If a gamma-ray burst occurred in our home Milky Way galaxy, it could also lead to a mass extinction on Earth. A burst pointed in our direction might only last 10 seconds or so. And still, it would destroy at least 50% of Earth's ozone layer. Yes, in such a short period of time. Even a relatively small amount of ozone depletion is enough to cause serious harm to our planet's natural sunscreen. And wiping out ozone on a large scale can wreak havoc, finishing huge numbers of species, starting with the ones living in the upper levels of the ocean. Gamma rays also break apart atmospheric oxygen and nitrogen. These gases turn into nitrogen dioxide, commonly known as smog. If this smog blanketed Earth, it would block out sunshine and trigger a global ice age. But our ultimate fate is much more dramatic than any of these scenarios. Most life on Earth will eventually disappear due to lack of oxygen after solar activity causes atmospheric oxygen to drop back down to the level it had been before the Great Oxidation Event occurred. The sun ages and puts out more and more energy. At one point, around 1 billion years from now, Earth will reach the point where atmospheric carbon dioxide will begin to break down. That's when oxygen-producing plants and organisms will disappear. Earth won't have enough life forms to sustain the oxygen-rich atmosphere all living beings on our planet need. This process may take as few as 10,000 years, and it seems to be unavoidable. Luckily, we still have around 1 billion years to figure out how to save ourselves.
You wake up, gasping for air, struggling to peel yourself from your bed. When you do manage to get your feet on the ground, it feels like they're glued down tight. You're twice as heavy. It feels like you're carrying another you on your shoulders all day long. Well, congratulations. You've woken up on an Earth where uncontrolled experiments with dark matter have doubled the force of gravity. Mass panic happens when over 8,000 aircraft fall as soon as the gravity spikes, crashing into buildings, forests, and oceans. And that's because airplanes suddenly lost the balance between the pull of gravity and the lift force necessary to keep them cruising. Pilots did attempt to save their planes, but GPS failed as satellites swiftly moved. After a month, humans begin to look more and more like chimps. Bones are getting thicker, and the immense force constantly pulling people down is squashing their spines, making everybody bend over. People start figuring out that walking ape-style on all fours helps with better balance and stability. And that becomes a big deal, since even tripping over a tiny rock could lead to a nasty fracture. Falls not only get more intense due to the extra forces on bones and joints, but they also happen faster. Gravity's pull doubles the acceleration force, increasing it from 32 feet per second to 64 feet per second. Your house is not a safe place anymore. Old buildings and bridges all over the world are now collapsing. Inside those still standing, residents get the scary feeling that the whole place is shaking, and cracks start showing up everywhere. It's dangerous to stay inside houses, as roofs are now twice their usual weight, and any rain or snow also feels twice as heavy. Car alarms are constantly going off because tree branches keep falling all over the place. Most trees simply can't bear the weight of gravity, and only strong and small plants survive, like cactuses and succulents. 6 months after the sudden change, supermarkets have a sinister vibe going on, with shelves nearly empty and people arguing over the last loaf of bread. You get frustrated to see that your favorite Japanese restaurant is now 5 times more expensive. And it's not just about salmon prices. It's rice that has become a rare luxury item, since the gravity boost has messed up the photosynthesis process, and the seeds are taking too long to grow. On the flip side, carrots are now cheaper than ever. They're sprouting and growing at lightning speed. People start eating so many carrots that human skin now has an orange glow from all that extra beta-carotene. Farmers are getting creative, using artificial supports to keep plants like tomatoes and corn on their feet. But even with all their efforts, it's hard to get a good harvest. Summer has arrived, and even your air conditioner can't relieve the unbearable heat. A sudden change in gravity disrupted Earth's orbit around the Sun, pushing it into a new, tighter elliptical path. Earth now passes much closer to the Sun than it used to, making your sunscreen simply surrender. The Moon's orbit has also had some dramatic changes, leading to more dangerous and extreme tide patterns. High tides are now higher and low tides are lower. This shift has also triggered widespread volcanic eruptions and earthquakes on an unprecedented scale. Earth's crust starts to rupture across vast areas, unleashing planet-wide lava flows so intense that living on Venus begins to sound like a pretty good idea. 5 years later, people notice that puppies are begging for food twice as much, but they are taking more time to grow. Breeds like beagles look thinner and their leg bones are getting heavier. Even insects, such as locusts, now have thicker hind legs to keep those jumps going. Sea creatures are being crushed by the much greater weight of the water around them. That's not a big deal for animals used to deep ocean pressures, like the anglerfish, but crabs and lobsters are really struggling since they live in shallow waters. Sloths and monkeys develop a stronger grip so they won't fall off trees. For carnivorous animals living in jungles or savannas, life is a real challenge because any animal the size of a wolf or bigger can't run without breaking a leg. Large predators like lionesses are starving because they can't move fast enough to catch their prey. Tall trees like palms and pines also go through evolutionary changes. They get beefier trunks and only grow about half as tall as usual. This way, water and nutrients can travel from the ground up to their leaves without struggling against gravity so badly. 10 years have passed since gravity increased. Airlines have finally made changes to prevent commercial flights from nosediving. The wings of airplanes are now longer. Pilots have learned to fly at altitudes twice as high, and flight speed has increased by 41%. To avoid people getting extremely nauseated and dizzy during takeoffs and landings, seats are now fully horizontal, like first-class bed-like setups, specially designed to minimize the nasty effects of gravity ×2. Flight attendants are trained to raise the seat at the passenger's feet after they pass out, so that blood can return to their head. The thing is, when gravity gets a power boost, it yanks your blood down to your feet and hands even more than usual, making your heart work extra hard to pump that blood around, especially to your head. 50 years have passed. Women in their 30s look like they are 60. Higher gravity decreases collagen synthesis, so even though they're still young, they're dealing with more wrinkles and fine lines, and their skin has already lost a big part of its elasticity. Wounds as small as a pimple pop or a paper cut also take much more time to heal. So people are excited about the creation of a Band-Aid made from fish skin from cod or tilapia that promotes local blood circulation and speeds up the healing process. People have also got used to wear exoskeletons made of titanium, which support and enhance the wearer's strength. This technology features cool joints at the places that copy humans' natural movements, giving people more flexibility and letting them move around more easily. Prototypes of personal flying devices start popping up after 100 years. The Gray Flyer is like a jetpack made of carbon nanotubes, making the structure strong without adding much weight. Instead of using fuel for propulsion, the device has these super thin but high-tech solar panels. Investors are still not sure if humans could fly long distances with it, but the Gray Flyer definitely can help people tackle tasks that have become almost impossible, like climbing a mountain or grabbing something from the attic. Things at the gym are pretty different too. The anti-gravity treadmill is a favorite among fitness enthusiasts because it uses air pressure to lift users, reducing the discomfort of gravity while running. People can also lift weights in booths when the gravity settings are customized. When training with G-force set at 3 or 4 times the new normal, muscles get stronger, making double gravity seem more bearable. However, the maximum set is 4.6, otherwise bones might crack. Over 500 years have passed. Thanks to these amazing technological creations, humans can now handle and establish colonies in other parts of the universe. A popular choice for family vacations is Kepler 452b, a planet about 60% larger than Earth, orbiting in the habitable zone of a sun-like star. Kids especially like that place, as oceans have been discovered and hotels have been built near rocky beaches. On the other hand, traveling to places in the universe with lighter gravity is like going to an oasis of tranquility. So Mars and the Moon have become known for amazing yoga retreats. With their gravitational forces much weaker, people can breathe more easily there and move around with more freedom. Keep in mind that these trips are expensive, so you might want to start saving up now.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long, and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, two tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe.
Hold on to your hats, folks, because we're about to embark on an incredible journey. With the help of super smart scientists and their studies, we've asked AI to take us back a mind-blowing 2 billion years in time and show us what our awesome Earth looked like. So buckle up and let's find out. Once upon a time, way back when Earth was just a baby, around 4.5 billion years ago, hopping into a time machine and paying a visit would have been a big mistake. The whole place was a hot mess. First of all, the ground was still all gooey and molten, so landing your time machine would have been a major risk. Now, as soon as you tried to get out, you would see a completely different Earth compared to what we know today. The landscape is a patchwork of rugged mountains, sparkling seas, and vast stretches of land. Picture massive volcanoes erupting in fiery bursts, shooting gases and ash into the air. It's like a crazy fireworks show. And even if you had a fancy new machine that could hover and had special shields to handle the heat, you'd still have a hard time breathing. You see, the early Earth's atmosphere is a bit moody. Thick clouds hang in the sky, casting mysterious shadows on the land below. The air is as thin as a whisper and filled with all sorts of interesting gases like hydrogen and helium. Carbon dioxide swirls around, giving everything a vibrant green hue. Water vapor drifts through the air, creating a sense of humidity and a refreshing mist. Oh, and there might be a hint of ammonia and methane just to keep things interesting. Lots of cool gases, huh? But wait, there's something missing. Oxygen. So if you take a deep breath, you won't feel that familiar rush of air filling your lungs. On land, there are no lush forests or towering trees just yet. Instead, you find rugged, rocky terrains. Some of these ancient rocks bear the marks of intense forces, collisions and earthquakes that have shaped the land over millions of years. But amidst all this ancient beauty, something amazing is about to happen. Life, in its early stages, is evolving and preparing for its grand entrance. Simple organisms, like algae and bacteria, rule the scene. They thrive in the oceans, using the abundant carbon dioxide to grow and multiply. The waters are teeming with activity, with colorful, microscopic life forms buzzing around like a busy city. These tiny organisms are working hard, releasing oxygen as they go about their business. They're like little factories, slowly changing the composition of the atmosphere. So this is what the early Earth looked like, more or less. But why was it so nasty? And how could it have changed so much since then? You see, Earth's heat came from all sorts of crazy things happening during its formation. First off, there was some serious heat already packed into the objects that came together to make our planet. Then, as Earth grew bigger and stronger, its gravitational force got a major power boost. It pulled in more stuff, but it also gave Earth a massive bear hug, squeezing everything tightly. And you know what happens when things get squeezed? They heat up like a pressure cooker. This crazy heating had a huge impact on Earth's structure. Picture Earth as a mixed-up bag of rocks, metals, and minerals. But as things heated up, The rocks and metals got so toasty that they melted. And guess what? The denser metals sank to the center and became Earth's core, while the lighter rocky stuff floated up to become the crust and mantle. It was like Earth decided to unmix itself, creating separate layers. Scientists call this wild separation differentiation. But the heating didn't stop there. With all this mixing and moving around, Earth got even hotter. It was like turning up the heat in a giant planetary oven. All this crazy heat had some serious consequences. Earth's high temperature made everything super speedy. Tectonic plates were dancing like there was no tomorrow, making the surface super active and full of geological shenanigans. Oh, and that's not all. Earth also got showered by some serious cosmic visitors. Imagine this. While Earth was busy gathering up all sorts of space debris during its formation, the rest of the solar system was causing some major chaos. Saturn and Jupiter decided to shake things up by changing their orbits, sending a whole bunch of massive objects hurtling towards poor Earth. These collisions were no joke. They packed a punch that melted minerals in Earth's crust and even vaporized them. These booms were so intense that they even blew gases right out of Earth's atmosphere. Talk about a wild fireworks show. Believe it or not, we can still spot ancient battle scars from these collisions. It takes some careful detective work, but we can catch a glimpse of their aftermath. For example, there's this place called the Manitsok Crater in Greenland. Even though there's no actual crater to see, we can examine rocks that were chilling 12.5 to 15.5 miles below Earth's surface back in the day. And guess what? They bear the marks of intense and sudden shock. Now that's some tough neighborhood. The wildest collision of them all was with a planet called Theia. Theia, about the size of Mars, crashed into Earth with a mighty bam! It was a colossal event that changed everything. Theia's metal core fused with Earth's core, while the outer layers of both planets got shattered and tossed into space. The result? A beautiful ring of debris encircling Earth. Now here's the coolest part. That debris didn't just float around forever. It started to come together, like puzzle pieces finding their match. And voila, we got our very own moon. Can you believe it? And this incredible moon-making process might have taken as little as 10 years or even less. Crazy, isn't it? Scientists call this whole moon-forming extravaganza the giant impact hypothesis. So next time you gaze at the moon in the night sky, remember that it's actually a huge chunk of our own planet. And by the way, Earth also had quite the adventure trying to create its atmosphere. In the beginning, our planet's first attempt at an atmosphere didn't go so well. It had a thin layer of hydrogen and helium that came along with all the stuff it gathered. But those gases were like sneaky escape artists and decided to float away into space. Bye-bye, gases. Luckily, Earth didn't give up. It went for a second round, and this time it was much more successful. Volcanic eruptions came to the rescue. They spewed out all kinds of gases like water vapor, carbon dioxide, and a whole bunch of other funky ones. Even meteorites and comets joined the party, bringing lots of water and nitrogen to the mix. Earth's atmosphere was becoming quite the party. But here's the funny thing. There was no oxygen to be found during the second experiment. Nope, not a single breath of it. The oxygen that was produced by the sun's rays splitting water molecules got gobbled up by chemical reactions faster than you can say, oxy-bummer. It wasn't until Earth's third experiment came along, life, that things started to change. Photosynthetic organisms took center stage and used all that carbon dioxide in the air to make their food. And guess what? They released oxygen as a sidekick. Eventually, the organisms started belting out so much oxygen that it overwhelmed the reactions, and it began to fill up the atmosphere. It took a while, though, and it wasn't until about 350 million years ago that we got the oxygen levels we have today. About 21% of the air we breathe. So, from fiery volcanoes to mysterious oceans, this glimpse into the past reveals an Earth vastly different from the one we know today. It's fascinating to explore the ancient landscapes and imagine the early stages of life taking shape. Thanks to AI, we can catch a glimpse of Earth's remarkable history and appreciate the wonders of our ever-changing planet. So, stay tuned for more interesting journeys.
Have you ever thought about Earth itself as an intelligent, well, not creature, but maybe an entity? Like it has a mind and some survival instincts of its own. When said like this, it sounds like you're about to watch a fantasy movie where the planet we walk and live our daily lives on will suddenly wake up, realize it doesn't like us that much after all, and just go crazy. Hope not. But we're not actually talking about such scenarios, more of the idea that the collective activity of life, like microbes and plants, can change a planet and give it a life of its own. It's like the planet has a green mind. The metaphor of Earth as a living planet makes sense. Creatures across the globe crawl, swim, walk, and fly through the uppermost layers of our land, ocean, and sky. Plants cover much of our world. Plus, there are viruses and bacteria in the water, soil, and even atmosphere. Now imagine all the living things on Earth, like plants, animals, and microbes, as a giant team working together. They have different jobs, but they all do their thing to make the planet a better place to live. For example, plants make oxygen that we breathe, and animals help pollinate flowers. Together, they form the biosphere, which is like the Earth's team of life. We're far from that, but it's still nice to imagine. At the moment, our civilization is in the stage scientists named an immature technosphere. That means we're still too focused on using technology that doesn't always do good for our planet. We don't have a planetary intelligence or a collective understanding of what needs to be done to do better for our planet. Instead, we're all just doing our own thing. I mean, we're not at the worst stage. Researchers have come up with 4 stages of Earth's past and future to explain how planetary intelligence could impact the long-term future of humanity. The first stage is what we call the immature biosphere. It's when life first started on Earth, billions of years ago. Only microbes were there on the bare land without any vegetation. There wasn't any global feedback, which means these microbes couldn't yet affect Earth, its atmosphere, or other systems in any way. The second stage is the mature biosphere, which was 2.5 billion to 540 million years ago, when stable continents formed and the biosphere started to have a strong influence on the Earth. The third stage, known as immature technosphere, is where we are now, with interlinked systems of communication, technology, transportation, electricity, and computers that draw resources from Earth's systems and affect the biosphere. The fourth stage, also known as the mature technosphere, is where Earth should aim to be in the future. It means technology will benefit the entire planet. We'll use sustainable forms of energy, like solar power. Planetary intelligence is the sign of a mature planet, and researchers are trying to figure out how we can move towards it. So, things we do on an individual level do matter. The collective activity of life, like microbes or plants, can change a planet and make it more than just a lifeless rock floating in space. Through the biosphere, our home planet kind of figured out how to host life by itself billions of years ago, and it's still going. Now we need to figure out how to have a similar kind of self-maintaining system, but this time with the technosphere. It's hard to imagine planets could generally become sentient, like Pandora or some other imaginary conscious world out there. There are a few reasons for that. First, planets form based on how different materials like rocks, gases, and liquids gather around a new star. It's like you have a big family gathering, where everyone brings different ingredients to make a delicious dish. And just like how these ingredients won't suddenly turn into a living being, the materials that make up a planet won't just turn into self-aware creatures. On Earth, after billions of years of complex chemical reactions, some molecules started to replicate themselves and carry information. That's how life on our planet began. And Earth is the only such example we have. Here's the second reason. Imagine you have a big garden where you plant a lot of mushrooms or bacteria, hoping they'll become really smart and help you take care of the garden. But mushrooms and bacteria don't have brains like we do. It's not like they need it anyway. Having a big brain is really expensive for animals too. It takes a lot of energy to keep it running. So, animals only become as smart as they need to be to survive and thrive in their environment. Dogs and cats are pretty smart because they need to be able to avoid danger and find food. They don't need human kind of intelligence for things like building houses, creating art, or inventing new technologies. So, it would be hard to bring all living beings and plants to the same level of intelligence. The third reason why it would be difficult for a planet to become sentient is the main rule of the animal kingdom. Life is all about survival of the fittest. Every creature is competing for resources like water, food, and space. But not only do different species compete against each other, but individuals within the same species also fight. Just think of how fiddler crabs fight for territory on the beach, or how wolf packs fight over prey. Or me, when I see an empty spot on a crowded beach. This kind of competition is not a good base for global cooperation. There are a couple of exceptions to this rule. For example, ants. They may not be the brightest creatures on the planet, but when they come together in colonies, they can achieve amazing things, like gathering food that's way bigger than them, building nests, raising young, and even farming. In fact, they act like a superorganism called a hive mind, where every ant works together towards a common goal. Insects like bees and ants are very altruistic and work together to ensure their queen reproduces. If one large ant colony took over our whole planet, it could act as a single mind and work towards the colony's and planet's interests until they run out of resources. But in reality, it's hard to imagine any organism, even a superorganism, could reach such a level of self-awareness and consciousness. Number 5. How could we keep in contact? When it comes to communication, ants use pheromones and humans use nerves. Both of these methods work well for small organisms, but when it comes to a giant planet-sized entity, it would be hard to make such communication fast and efficient. So, communication within a planet-sized entity would be much slower than what we have in our homes, like our computers or smartphones. Oh well, we'll just continue dreaming about Pandora.
Black holes are some of the most enigmatic and sinister phenomenon in the universe. They can swallow up entire stars and planets, bending the very fabric of space and time. But what if Earth, our home planet, were to be caught in the grip of a black hole's event horizon? What would we see before the inevitable end? Well, let's have a look-see, okie dokie. So a black hole is like the bully on the playground. You avoid them at all costs. It's a region of space where gravity is so strong that nothing, not even light, can escape it. It's like Houdini in reverse. As with snowflakes, every black hole is unique. Each one has its own mass, spin, and charge. And they also come in different sizes, sort of like jeans. Petite, slim, regular, and husky, or something. Anyway, there are 4 sizes. The smallest black holes are the stellar mass kind. They're born when the massive star runs out of juice and folds in on itself. They're like the chihuahuas of the black hole world. They may be tiny, but they're feisty. They gobble up nearby matter like a hungry puppy. And even the smallest one is 3 times more massive than our Sun. Next up, we have the middle children of this cosmic family, intermediate mass black holes. They're too big to be born out of collapsed stars. Scientists believe that they may be created when several black holes merge into one. And even though they can't dominate galaxies, at least they can swallow up some nearby stars. Goody for them, huh? But do you know who can dominate a galaxy? The enormous monsters of our universe, supermassive black holes. They're the giants with masses ranging from millions to billions of times that of our Sun. And they play a crucial role in the growth and formation of their host galaxies. Finally, there are ultra-massive black holes. Trust me, you can't even imagine the size and mass of these guys. These cosmic eldritch horrors are extremely rare, but the ones we know can devour entire galaxies like Pac-Man. So, what happens if you get too close to a black hole? Or more like, what would you see in your last moments? Well, first, you reach an event horizon. It's like a point of no return, an invisible boundary that marks the edge of a black hole. And here's where things start to get really weird. For example, time starts to slow down. Not for you, for an outsider watching you from a safe distance. If you were falling into a black hole, you wouldn't feel any different. But if you were watching someone else fall into it, you'd see them slow down and eventually freeze in time, like in a paused video. As you get even closer, you would start to see some pretty mind-bending things. The gravity would cause the light around you to bend and distort, creating a sort of funhouse mirror effect. You might even see a halo of light around the black hole, known as the photon ring, or jets of high-energy particles spewing out from the black hole's poles. You can actually get pretty close to a black hole without feeling any major effects. It's only when you cross the event horizon that there's no going back. Your goose is cooked. After crossing this boundary, you'd be unable to see anything. For the person watching you from the outside, it would be as if you had suddenly disappeared. Meanwhile, you might start feeling a bit stretched out, like a piece of spaghetti. This is because the gravity is so stark that it's pulling you in different directions at once. There's even a scientific term for it, called spaghettification. We'll cover linguinification in another video. Now that you're inside a black hole, you're taking aim at the singularity. It's a point of infinite density in its center, where all matter is crushed down to a single point. It's like trying to fit an elephant into a tiny matchbox. Everything gets squished together until it's as small as it can possibly be. Which means it's time to wave goodbye, I guess. And if all that sounds scary, here's another fun fact. Black holes are not rare at all. Actually, there's one in the center of each galaxy, including our own Milky Way. So, does it mean that we'll eventually be sucked into it? And if so, how exactly would it happen? Well, let's see. Imagine a black hole approaching our solar system. At first, it appears as nothing more than a tiny speck in the distance. But as it gets closer and closer, its gravitational pull begins to wreak havoc around. Planets start to veer off course, asteroids are flung into oblivion, and comets are shattered into a million pieces. But just like waiting for the sausage to be served in a German restaurant, the worst is yet to come. Yeah, like that joke. Soon, it inevitably reaches the Earth. First, our planet's atmosphere would be pulled toward the black hole, triggering a massive windstorm. And there'd be huge waves on the oceans, the water itself being distorted by gravitational forces. Imagine seeing seas and oceans getting stretched out. Earth's magnetic field is generated by the motion of molten iron in the planet's core. But now, the extreme tidal forces of the black hole would disrupt this motion, causing the magnetic field to weaken and distort. All this would cause massive earthquakes and volcanic eruptions, as the planet's crust and mantle were pulled apart. All infrastructure and technology would be completely destroyed. Buildings, bridges, and roads would be torn apart. Okay, let's hit the pause button. Pretty horrifying, isn't it? Nah, but don't worry. You wouldn't have even seen that much, because you would have felt the effects of the black hole much, much earlier. Well, Back to the Future. We'll lose our magnetic field even before everything started to collapse. And this means not only that the weather and climate will become terrible, we'll also be exposed to extreme radiation. These gamma rays and the heat from the black hole could drastically change our planet. Say ta-ta to all our beautiful nature. At least misery loves company. We won't be the only ones affected by a black hole, which is probably even worse. As this beast engulfed the entire solar system, it would consume about everything. One immediate effect would be the disruption of the orbits of asteroids, comets, and all the other bodies. The planets would begin to deform and stretch, their surfaces warping like molten metal. The sun itself would be affected, its surface contorting like a glob of putty. And yeah, all this is scary even to imagine. But now, breathe and relax, because none of this will ever happen. This is the bright side, remember? Your infinitesimal odds of winning the big lottery are even better than the Earth ever being swept into a black hole. The nearest black hole to our solar system is called Gaia BH1. Discovered by scientists in 2022, it's found in our own Milky Way galaxy, about 1,600 light-years away from Earth. Gaia BH1 is about 10 times the mass of our Sun, which makes it a stellar mass black hole. It's not very interesting on its own, but its discovery has supplied valuable insights into the behavior of these cosmic monsters. But as you can see, even the closest known black hole is over 1,000 light-years away. They move very slowly, and they'll never get so close to our system to pose some kind of a threat. Hey, but didn't you say there's a black hole in the center of the Milky Way galaxy? Doesn't that mean it's going to eventually hoover up our entire galaxy, you may ask? Maybe not in that voice. Well, don't worry. The correct answer is no. The one in the center of our galaxy is called Sagittarius A star. You may remember it from that viral blurry photo that circled around the internet a few years ago. This black hole is indeed very massive and has a strong gravitational pull, like two 8th graders in love. However, it's still a small beam. It only affects objects that are close to it. The objects in the galaxy are all too big and move too fast to be pulled in by black holes. Nevertheless, they're still fascinating objects to study. Scientists are still trying to unlock the mysteries of black holes. And even though they'll never be dangerous to us, they're still a huge reminder of the incredible power of our universe. Now I think I'll turn my attention to the incredible power of chocolate.
It all started with a minor change on our planet. At first, people noticed the moon had become brighter and a little bigger. But nobody paid attention to this. The moon affected tides all over the world. The water flooded the beaches, but it wasn't a tragedy. A lot of fish came close to the shores. People found giant squid, anglerfish, and other creatures next to the coast, although they usually live in the dark depths. New, stranger things happen every day. Birds no longer fly to the south in winter. They gather in huge groups, flying around cities with no purpose. The moon used to help them navigate in nature, so they can't figure out which way to fly anymore. In the boundless waters of the world's oceans, ship captains notice that compasses are now unstable. The arrow is pointing in different directions since the Earth's magnetic poles have changed. People realize the moon has started to approach Earth for an unknown reason. The moon's gravity affects the gravity of our planet. This entails changes in the climate, the behavior of all living beings, and the magnetic field. Now, it rains in the driest places and gets hot in the coldest lands. It's knocking down ecosystems all over the planet. People living near forests hear wolves howling all the time. The moon drives these animals mad. The Earth's natural satellite is growing in size and lights up the night much brighter. Nothing critical has happened yet. People don't panic because they don't want to believe the end is coming. But then, one day, the moon reaches a critical point. You're walking down the street listening to music, and at that moment, someone pushes you. Okay, maybe that guy is late for work. You keep walking, and a girl coming by hits your shoulder. "I'm sorry, she says, and goes away. You've noticed the fear in her eyes. You look ahead and see people running towards you. You take off your headphones and hear screams and sirens. People leave their cars and run away. Hundreds of seagulls are flying in the sky. You hear a strange noise among all the sounds of chaos. It seems to be water. How is this possible? You're in the city center, a few miles from the shore. But there's no time to think. You notice a huge wave flooding the streets and heading straight to you. You run into a building and go up to the 10th floor. From here, you're watching the water filling the city. The strong stream blows all cars, one-story buildings, and trees off the road. You notice a shark and other fish in the water. People are hiding in houses and on the roofs. The whole city is quickly plunging into a catastrophe. The TV is working in the building where you're hiding. You learn that floods are occurring all over the world. Massive tsunamis cover coastal cities. In some places, waves reach the height of a 30-story building. Many towns have been washed off the face of the earth. The moon is too close to Earth, and massive floods are just the beginning. The moon flies around Earth and helps to keep our home on its axis. The moon provides climate stability and helps living organisms develop. But now, this balance is broken. The moon is approaching and changing our planet's gravity. Earth can tilt slightly to the side and provoke massive floods around the world. Imagine that you're holding a round glass of water. Tilt it a little. See how the liquid moves from one side to another? The same thing is happening now with the oceans. But the moon is not just approaching us. It's flying around the planet and getting closer with each circle. It causes natural disasters in different locations on Earth all the time. Now the ocean floods one side, and a few hours later, another. So you see all the water going back from the streets to the shore. The oceans may return to the city again by the end of the day. Wait a minute. It seems the end of the day has already come. You notice that the sky has become dark. It's weird, because it's only 3 p.m. The moon changes Earth's rotation speed and makes the day go faster. The moon covers almost the entire sky and brightly illuminates our planet. You see huge lunar craters. It's so close that you can still see it even when the sun shines. In some places, the passing moon obscures the sun. The water is leaving the streets and everyone goes outside. At this moment, an earthquake begins. The road is cracking and the houses are collapsing. There are landslides on the street. Tectonic plates are shifting all over the planet. Imagine two magnetic balls that are approaching each other. So, one ball is the moon and the second one is Earth's core. What do you think will happen to what's above the core? That's hundreds of thousands of miles of the Earth's crust. And now, it's all moving. Destructive cracks are emerging all over the world. The planet's highest mountains break down and turn into a pile of stones. The seabed cracks and releases magma from the underground depths. Volcanoes wake up and erupt magma. Clouds of volcanic ash cover the sky from the sun and the glowing moon. But the scariest thing is still ahead. A collision is inevitable. The moon flies around the planet like a ball in a round glass with a hole in the center. This force drives clouds all over the planet. Now there's a thunderstorm, but in 5 minutes, it will be snowing. Then the night comes, and it starts raining. Water droplets consist of mud and volcanic ash. It's difficult for people to breathe without gas masks. Atmospheric pressure is constantly changing. Some people experience severe migraines, and some have sore joints. But there's no time to think about your health. Humanity needs to figure out how to save itself from the collision. A new gravitational order will come when the moon crashes into Earth. Continents will change their shape. They will combine into one giant piece of land or split into 100 smaller ones. The energy of the collision can burn all the oxygen in the atmosphere and make the planet unsuitable for life. Hiding underground also makes no sense because of deep earthquakes. People decide to spend their last hours with loved ones and their families. The moon is getting closer. It's now at the same distance as the International Space Station. The moon covers the sky. Many cities are in the shadows because of the waves. Tsunamis, several miles in height, crash down on the ground. Millions of tons of magma collide with the ocean. Billions of gallons of water just evaporate. Moisture rises into the air, mixes with ash, and floods the land in the form of giant cumulus clouds. You've accepted the complete destruction of the planet, but something strange happens to the moon at this moment. You notice giant cracks appear on it. The moon slowly begins to divide into two parts. Both halves crumble into hundreds of large pieces. It's just falling apart. The Earth doesn't have a natural satellite anymore. It's just a pile of giant space rocks. But why is this happening? There's a space around our planet called the Roche limit. In this place, the gravity of Earth is stronger than that of the moon. This means that the forces holding the moon together are weaker than those that tear it apart. People are cheering. The Roche limit has saved the planet. The moon won't hit us. It breaks up into millions of fragments and forms a circle around our globe. Now, Earth looks like Saturn. A belt of moonstones surrounds us. Huge chunks destroy everything in their path, all the space debris. The satellites are no longer working. Humanity loses its means of communication and navigation. People will have to use paper maps again. The moon held our planet's orbit at a certain angle before these events. Now the axis is tilted differently. One hemisphere becomes closer to the sun, and the other plunges into shadow. The North Pole and the Arctic may turn into hot deserts, and the equator of the planet may be covered with ice. Winter and summer can last for years. The moon's remnants fly around Earth, but some of them fall on our planet. Lunar meteor showers destroy cities and create giant craters. All these events lead to the massive destruction of life on Earth. It will take hundreds of thousands of years to adapt to the new world.
Hey, I want to show you something. Let's take a little trip off of Earth and park our spacecraft somewhere near the moon. We're now almost 240,000 miles away from our home planet. That's almost 100 times the width of the United States. Now we've brought a special set of tools with us, a giant hammer and an enormous chisel. Place the chisel at the Earth's North Pole and strike its head with the hammer. The Earth cracks open like an eggshell and we see another planet. This is Theia, and it's hiding inside our planet like a yolk in an egg. If you want to find out how it got there, you'd need to travel back in time 4.5 billion years. This beautiful nebula is what will eventually become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Over time, this jigsaw puzzle of debris becomes denser and heavier. The temperature inside the giant is rising. Soon, it gets so high that it'll trigger a nuclear chain reaction. One more second, and bam! There's an explosion so powerful that the shockwaves travel far into deep space. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. But we're interested in that small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core while the oceans of lava are gradually cooling down. But some millions of years later, after the Sun's birth, you notice another small object. Here comes Theia. This small planet was formed at about the same time as Earth, and right now, it's following a crazy spiral trajectory at enormous speed. Scientists believe Theia was like a ball Jupiter and Venus played around with. Venus would pull Theia in one direction, and then Jupiter would pull it right back. But what makes up 99.8% of the mass of the solar system is the Sun. It's what makes Theia move into almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Theia is roughly the size of Mars, as wide as the Atlantic Ocean from New York to Portugal. At this point, the collision can't be avoided. Theia is traveling towards Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If this smaller planet would crash into Earth at a particular angle, Earth would most likely be torn apart, as well as Theia itself. The collision would cause a huge blast visible on other planets, even on a bright day. Nothing would be left but some burning dust and debris. Even if Theia only slightly grazes the Earth, it'll still knock out a sizable chunk. But the collision with Theia happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock, and the shockwave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site, which soon gets filled in with boiling lava. The remnants of Theia and the ejected fragments of Earth begin to orbit our planet. According to one theory, these fragments actually form two moons. At first, they travel together, but one day they get too close to each other and collide, forming one large space body. The other theory claims that all the loose shards get pulled in by the remnants of Theia, and that sometime after that, they form the moon, as we know it today. At this point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Theia, though we have different seasons and 24 hours in a day. Now, Earth also has these things called lithospheric plates. These are enormous solid land masses that make up the crust of our planet. After the collision with Theia, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet, so Earth gains a kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over the next nearly 4 billion years, simple single-cell organisms evolve into the kinds of complex life you see today. According to scientists, a collision like we had with Theia is a very rare event. The probability that somewhere out there there's a planet like ours that has survived the same catastrophe is even rarer still. This may be the reason why we have yet to find other traces of other civilizations out there in space. Meanwhile, the remains of Theia are still here on Earth. Of course, it doesn't look like an actual entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see two huge lava blobs the size of large continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Theia. They didn't mix with the Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise these lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Theia might be on the moon. The Apollo space missions brought back many soil samples for analysis, which led scientists to conclude that the moon is very similar to the Earth in structure. Someday in the future, people could drill deep down and take samples of the moon's crust. Then they'd analyze the blobs from Earth, and if their structure matched, it would be undeniable proof that Theia did hit Earth 4.5 billion years ago and gave us the moon. But for the time being, Theia remains an unsolved mystery. Scientists are still not sure that the planet actually existed. The whole idea does perfectly fit the model of the moon's creation, but it's also possible that this incredible collision may have never happened. Now, let's travel 41 light years away from Earth to the planet 55 Cancri E. It's about twice the size of Earth and 8 times heavier. Let's take out our giant hammer again and use it to hit the chisel. The planet cracks, and you see it's a giant diamond. The temperature on this planet is tens of times higher than on Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon, and the structure changes. First, it turns into graphite, but then add just a bit more pressure, and the graphite turns to diamond. On Earth, diamonds form at depths 60 miles below sea level, where the pressure is 50,000 times greater than that on the surface. And the temperature there averages over 1,000 degrees, which is as hot as fire. Diamonds are often ejected closer to the surface in volcanic eruptions, but still, people mostly have to dig mines 1,500 feet deep to find these beautiful gems. Currently, the Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now, imagine a diamond the size of an entire planet. Now, let's fly back to our solar system. Our destination now is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% of the mass of Earth. Its surface is enclosed in an icy crust that's about 19 miles thick. Europa is completely covered in water. It's freezing here, 3 times colder than that of the North Pole and Earth. The water turns to ice almost instantly. But the ocean beneath the surface is still liquid. Europa has a gravitational relationship with Jupiter, just like the moon with the Earth. This creates tidal forces that heat Europa's core, which then melts the ice around it. The result is a huge ocean, 2 or 3 times larger than that of Earth's oceans combined. Scientists believe that water is one of the essential ingredients for life. This means that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans, though the water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria could live there. Europa is almost the same age as Earth, so there has been enough time for living organisms to appear and evolve. Who knows, maybe some advanced civilization is already blooming under this crust of ice. They might be building big cities and dreaming of conquering space. But for now, all we can do is speculate, and maybe someday send a probe to Europa to find out if life is possible there. Hey, I want to show you something. Let's take a little trip off of Earth and park our spacecraft somewhere near the moon. We're now almost 240,000 miles away from our home planet. That's almost 100 times the width of the United States. Now we've brought a special set of tools with us, a giant hammer and an enormous chisel. Place the chisel at the Earth's North Pole and strike its head with the hammer. The Earth cracks open like an eggshell and we see another planet. This is Theia, and it's hiding inside our planet like a yolk in an egg. If you want to find out how it got there, you'd need to travel back in time 4.5 billion years. This beautiful nebula is what will eventually become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Over time, this jigsaw puzzle of debris becomes denser and heavier. The temperature inside the giant is rising. Soon, it gets so high that it'll trigger a nuclear chain reaction. One more second, and bam! There's an explosion so powerful that the shockwaves travel far into deep space. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. But we're interested in that small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core while the oceans of lava are gradually cooling down. But some millions of years later, after the Sun's birth, you notice another small object. Here comes Theia. This small planet was formed at about the same time as Earth, and right now, it's following a crazy spiral trajectory at enormous speed. Scientists believe Theia was like a ball Jupiter and Venus played around with. Venus would pull Theia in one direction, and then Jupiter would pull it right back. But what makes up 99.8% of the mass of the solar system is the Sun. It's what makes Theia move into almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Theia is roughly the size of Mars, as wide as the Atlantic Ocean from New York to Portugal. At this point, the collision can't be avoided. Theia is traveling towards Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If this smaller planet would crash into Earth at a particular angle, Earth would most likely be torn apart, as well as Theia itself. The collision would cause a huge blast visible on other planets, even on a bright day. Nothing would be left but some burning dust and debris. Even if Theia only slightly grazes the Earth, it'll still knock out a sizable chunk. But the collision with Theia happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock. and the shockwave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site, which soon gets filled in with boiling lava. The remnants of Theia and the ejected fragments of Earth begin to orbit our planet. According to one theory, these fragments actually form two moons. At first, they travel together, but one day they get too close to each other and collide, forming one large space body. The other theory claims that all the loose shards get pulled in by the remnants of Theia, and that sometime after that, they form the moon, as we know it today. At this point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Theia that we have different seasons and 24 hours in a day. Now, Earth also has these things called lithospheric plates. These are enormous solid land masses that make up the crust of our planet. After the collision with Theia, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet, so Earth gains a kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over the next nearly 4 billion years, simple single-cell organisms evolve into the kinds of complex life you see today. According to scientists, a collision like we had with Theia is a very rare event. The probability that somewhere out there there's a planet like ours that has survived the same catastrophe is even rarer still. This may be the reason why we have yet to find other traces of other civilizations out there in space. Meanwhile, the remains of Theia are still here on Earth. Of course, it doesn't look like an actual entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see two huge lava blobs the size of large continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Theia. They didn't mix with the Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise these lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Theia might be on the moon. The Apollo space missions brought back many soil samples for analysis, which led scientists to conclude that the moon is very similar to the Earth in structure. Someday in the future, people could drill deep down and take samples of the moon's crust. Then they'd analyze the blobs from Earth, and if their structure matched, it would be undeniable proof that Theia did hit Earth 4.5 billion years ago and gave us the moon. But for the time being, Theia remains an unsolved mystery. Scientists are still not sure that the planet actually existed. The whole idea does perfectly fit the model of the moon's creation, but it's also possible that this incredible collision may have never happened. Now, let's travel 41 light years away from Earth to the planet 55 Cancri e. It's about twice the size of Earth and 8 times heavier. Let's take out our giant hammer again and use it to hit the chisel. The planet cracks, and you see it's a giant diamond. The temperature on this planet is tens of times higher than on Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon, and the structure changes. First, it turns into graphite, but then add just a bit more pressure, and the graphite turns to diamond. On Earth, diamonds form at depths 60 miles below sea level, where the pressure is 50,000 times greater than that on the surface. And the temperature there averages over 1,000 degrees, which is as hot as fire. Diamonds are often ejected closer to the surface in volcanic eruptions, but still, people mostly have to dig mines 1,500 feet deep to find these beautiful gems. Currently, the Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now, imagine a diamond the size of an entire planet! Now, let's fly back to our solar system. Our destination now is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% of the mass of Earth. Its surface is enclosed in an icy crust that's about 19 miles thick. Europa is completely covered in water. It's freezing here, 3 times colder than that of the North Pole and Earth. The water turns to ice almost instantly, but the ocean beneath the surface is still liquid. Europa has a gravitational relationship with Jupiter, just like the Moon with the Earth. This creates tidal forces that heat Europa's core, which then melts the ice around it. The result is a huge ocean, 2 or 3 times larger than that of Earth's oceans combined. Scientists believe that water is one of the essential ingredients for life. This means that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans, though the water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria could live there. Europa is almost the same age as Earth, so there has been enough time for living organisms to appear and evolve. Who knows? Maybe some advanced civilization is already blooming under this crust of ice. They might be building big cities and dreaming of conquering space. But for now, all we can do is speculate. And maybe someday send a probe to Europa to find out if life is possible there.
You're driving to your sister's house when all of a sudden the sky changes. The cool weather becomes scorching hot in a matter of minutes. People who were going for casual autumn strolls have now taken off their jackets and are sweating. People who were planning on going for a weekend ski trip have canceled their plans at the last minute to head to the beach. It was sunset, but the sky has become as bright as day. You fish out your sunglasses and continue driving. Nothing seems normal, but people don't seem to care. You put on the radio and hear everyone panicking about the sun. Nothing is cohesive. They're jumbling up their words and saying a gazillion things at the same time. You take out your phone and see what's happening on social media, and it's all the same thing. Nothing is comprehensible. It's just people talking about how the sun is getting closer to the earth. Footsteps are clacking along a quiet hallway. A man dressed in a sharp suit is making his way to one of the most important meetings of his life. Adam walks through the meeting room while everyone is waiting to hear what he has to say. As the head astrophysicist, it's Adam's responsibility to figure out what is happening and not let the public know what's going on. Otherwise, the whole world will succumb to panic and mass hysteria, which won't be good. He takes a seat at the head of the table while everyone waits for what he has to say. The room is tense, and no one is saying a word. He takes off his glasses and places them on the table. Everyone is watching his every move. He takes a few files out of his folder and starts reading. His voice can command a room. My fellow colleagues, I'm afraid the worst has fallen on us. After countless hours of consistent observation and analysis, we have discovered that a piece of the sun has abandoned its orbit and it's making its way toward us. We still don't know which part of the sun, but we know that once it strikes us, we may not have an Earth to call home any longer. The tension in the room is palpable. Everyone looks at each other confused. Adam answers as many questions as he can, but he himself doesn't even have some of the answers. In a matter of minutes, the press leaks some voice recording of Adam's speech, and the world goes berserk. Back to you. You just heard a snippet from Adam's speech and aren't too convinced of its validity. Even though the sky is getting brighter by the second, there's still no reason to panic. You continue driving, and suddenly you sense an intense vibration. Your car lifts off the ground and the windows shatter. You get out and duck for cover. You saw a comet-like object strike down in the middle of nowhere, miles away. More of these objects look like they're heading toward the ground. You start your car and drive off, trying to find a place to hide. Ashes start covering the sky, which makes it even hotter than it already is. The earth is scorching. Meanwhile, traffic is piling up for people who want to escape but don't have any real place to hide. You eventually abandon your car and go on foot, trying to find a place to cool down and get away from the sun's rays. Even though ash is covering the sky, the sun is still blasting through it. You head to the woods and find a cave to cool down in. It's still hot, but at least you can calm down and figure out your next move from there. You get out your phone and try to see if there's any news updates on what's happening, but nothing seems to be updated. You keep refreshing it, but nothing works. Suddenly, you hear some people getting closer, and they order you to step outside of the cave. Adam is with the top scientists in the world trying to figure out a solution. Everyone is presenting him with solutions, but in the end, none of them are achievable. They've spent hours in the office, but with each passing minute, the sun is getting stronger and the sky is getting brighter. It feels like nothing can be done until Adam has an aha moment. He calls for everyone's attention and asks for the extra people who are not contributing to leave the room. He mentions that they need to launch a rocket into space that can divert the large mass heading toward the Earth before it breaches the atmosphere. They only have a few hours before the sky becomes completely dangerous and unsuitable for flying. As for now, all flights around the world have been canceled. There is only a small window of opportunity to get this rocket out there and save the world. Adam summons the best engineers he can find to adjust the rocket and the astronauts who will volunteer for the mission. They go into quick basic training and start planning for the next steps. After many briefings, they're ready, but they only have one shot at diverting the large object. The astronauts are ready and begin to enter the rocket. Suddenly, you pop up out of nowhere, dressed in a spacesuit. You're one of the prominent astronauts for the mission. Those people who found you in the cave were from NASA, trying to recruit you for the mission. You meet with Adam, and he quickly briefs you about your role. Because the mission is very last minute, there wasn't even time for Adam to sit with you and give you the proper training or brief. You enter the rocket and take your seat. The engineers and scientists gather around to make sure that everything is in order before takeoff. The large object is getting closer, and if the rocket is delayed, then it'll melt when it reaches the final part of the mission. You're strapped in and the rocket starts rattling. All systems are in order. 3, 2, 1, blast off. The rocket picks up and shoots into the sky. There are extra layers of visor shield protection, since it feels like you're getting closer to the sun. After a few minutes, the rocket leaves the Earth's atmosphere and is at the forefront of the large object. The rocket suspends itself in a certain strategic position, waiting for the right time to swat the object out of the Earth's trajectory. Meanwhile, everyone back on Earth is hiding in bunkers when the loose debris strikes. A cleanup team will be ready to get rid of the space rocks that will be scorching hot. The bunkers are equipped with food, water, and electricity in case they have to remain underground for a while. Only a few minutes left until the moment comes. You press a button and get ready to deploy a large spike that's as long as the Statue of Liberty. The spike is kept on a stand that's attached to the rocket. It will fire the spike like a bow and arrow and shoot it straight through the large object, breaking it before it melts. There's less than 1 minute before impact. The arrow is stretched and released. The tip of the arrow has a titanium drill that will continue drilling through the object as soon as it hits. The arrow is released and shoots through space, breaking little pieces of space objects along the way. As it speeds through, it finally hits the large object and drills through it. But nothing seems to be happening. The drill is barely getting through the center. Luckily, Adam had already thought of a backup plan. The rocket, still suspended in its spot, fires a laser where the spike is to speed things up. The laser starts melting through to get to the core. The object is getting closer and is speeding up. The object still hasn't broken into pieces yet. Less than 2 minutes until impact, and everyone is running out of options. Adam has one last trick up his sleeve. He orders everyone to evacuate the rocket and move to the backup pods. He wants to put the rocket on a straight collision course with the large object. There's too much confusion. Everyone, including you, quickly heads to the pods and ejects to a safe distance. These pods won't float around in space since they have pressurized air that allows the pods to move in whatever direction the driver wants. Everyone shoots out of the rocket while it goes full speed at the object. They're both going, heading for each other at full speed. There are only a few seconds until impact. The whole world is watching. This rocket is now the only hope there is to save everyone on Earth. The rocket starts melting before impact, and suddenly, a large shockwave ripples through the sky. The rocket was able to break the large object into many pieces. The problem now is the smaller debris falling onto Earth. But since everyone is in bunkers, they're safe. Adam and his colleagues celebrate. You and the rest of the astronauts are safe and make it safely back to Earth. The next phase for everyone on Earth is to rebuild everything that was destroyed. People will have to start everything from scratch, but this is only the beginning of a new chapter in life.
Let's cut the Earth in half. You can see all of its layers. Here's the inner core. It's about 40 times hotter than the inside of your oven. That's the mantle, an ocean of hot lava. Here comes the crust of the Earth, the solid surface on which our civilization lives. But if you look up, there are many layers besides the atmosphere and the ozone layer. Scientists recently discovered a strange bubble here, which protects our planet from radiation. And nope, it's not the Earth's magnetic field. This bubble is made of radio waves. Our planet grows like a Christmas tree in the radio spectrum. But we're interested in low-frequency waves, the ones that let us keep in touch with submarines. So, radio waves are like light waves, or regular ocean waves. Look at this one. The distance between the two peaks is the wavelength, and the number of these waves over a period of time is the frequency. For example, there are 10 waves in this interval of 1 second. So, can you guess the frequency of this wave? Yep, it's 10 Hertz. Cell phones use waves with a frequency of 300 to 3000 megahertz. So, add 6 more zeros to that number. But waves of that frequency don't penetrate barriers well. Think of how you lose your cell phone connection when you're driving through a tunnel. That's because there is metal inside. It's a conductive material that weakens the radio waves a lot. Salt water is also a kind of conductor. So, if the submarine is deep enough, the thick layer of water weakens the signal, and we lose communication. To maintain it, we send fewer waves but make them longer. In the same amount of time, the frequency of the short waves will be much higher than the frequency of the long waves. That's why they're called very low frequency waves. But, as it turns out, these waves travel all over the Earth and even into space. This is where things get interesting. The waves collide with particles of radiation from the sun. We think of the sun as a friendly giant giving us light and heat, but it actually emits a lot of harmful radiation. Each flare, or the electrical discharge of material on our home star, causes an even greater burst of radiation. These particles fly to our planet, just as radio waves do. They travel 93 million miles from the sun to Earth in 8 minutes and crash into our bubble, which acts as a shield. Basically, radiation particles from the sun accumulate in the radiation belts around the Earth. Our planet's magnetic field traps them, and a recently discovered bubble of very low-frequency waves lies right below this radiation belt. It helps us repel some of the harmful emissions. Analysis of old studies confirmed that the radiation belts used to be much lower and closer to Earth. But when our civilization began to use radio actively, our waves raised that belt higher. No one expected such an effect from simple radio waves, but it'll give us a way to protect astronauts in the future. When you're on Earth, its magnetic field keeps you safe from radiation. You can physically see it when charged solar wind particles make the air particles at the poles of our planet glow. This is an aurora. Next time you admire this beauty, know that it's actually the Earth saving you from some extremely harmful rays. But if you're outside the Earth's magnetic field, somewhere in space, I have bad news for you. Nothing protects you there. This is a big problem for astronauts who spend months on the International Space Station. Perhaps scientists will learn to create protective bubbles of very low frequency waves around space stations and spacecraft. The same is true for other planets. We're probably going to colonize Mars. There is no magnetic field there, and nothing can protect you from radiation. But if you create an artificial bubble there, you can reduce the harmful radiation. Another invisible bubble protecting us is the atmosphere. It's like a layer cake or an onion. Each level of the atmosphere has its own properties. The lowest layer that we live in is the troposphere. This layer contains 80% of the weight of all the air on the planet. It's also the main place where water vapor lives. And this is where the machine called weather works. The sun sends rays of energy to the Earth. Our planet's surface reflects them and heats the air in the troposphere. This makes it move and change places with the cold air, so all the wind, cyclones, storms, and tornadoes only happen in the troposphere, up to about 7.5 miles high. That's why commercial planes fly at an altitude of around 6 miles. The wind or other bad weather conditions hardly affect this area, and the air here is not as dense as it is down on Earth. Flying 1 mile above sea level is like moving through a biscuit. It's hard, but at a 6-mile altitude, flying feels like moving through light whipped cream. The plane almost feels no resistance, so it's a win-win. They save fuel and keep the passengers safe. A couple of significant downsides are that it's very cold and you can't breathe there. It's cold because there are very few air molecules to absorb heat from the ground and transfer it to each other. You wouldn't be able to breathe here for the same reason. That's why planes are equipped with oxygen masks, just in case. Let's go a little here. This is the stratosphere. There's even fewer air molecules up here, and that's where the weather probes fly. They're the kind of small balloons with computers people use to predict the weather. This part of the atmosphere also contains the well-known ozone layer. This is our shield against harmful ultraviolet radiation. Ozone is almost the same as oxygen, except it has 3 atoms in it. When harmful ultraviolet rays enter our atmosphere, they crash into the O3 molecule. The ray breaks the molecule into O2 and another oxygen atom. The ray itself is converted into heat, but the ozone regenerates quickly. A single oxygen atom joins the O2, and the ozone molecule is ready to protect us again. It's the invisible shield that protects us from radiation. It gave birth to all life on Earth. As our civilization developed, we started to emit freon gas into the atmosphere. We used to fill our old refrigerators with it. A single chlorine atom would detach from a freon molecule when in the air, and then it would bind a single oxygen atom. Now, the ozone can't regenerate like it used to. Fortunately, we banned the use of such harmful gases, and the ozone layer began to regenerate. Scientists expect it to fully recover in the middle of the 21st century. The stratosphere ends at about 31 miles. The next layer is the mesosphere, the coldest of them all. On average, it's about negative 140 degrees Fahrenheit. That's 5 times colder than your freezer. This is the layer of the atmosphere where incoming meteors start to ignite because of friction in the air. Then they will eventually burn up completely. The air here is too thin for airplanes or balloons to fly, but it's still too dense for satellites. So, this layer of the atmosphere is not well studied. The next layer extends from 55 miles above sea level to about 500. That's a little more than the distance between Las Vegas and San Francisco. Kármán line is situated in this layer of the atmosphere. This is the boundary between our planet and space. The thermosphere is where all our spacecraft and satellites fly. It's also home to the International Space Station. The temperature rises extremely. The air here is about 10 times hotter than your oven can produce. It's all due to solar activity. But you would never be able to feel this heat. The air molecules that carry the heat here are so small that you would literally float between them. Imagine a giant pool with only 3 drops of water. That's the thermosphere. And the highest layer of our atmosphere is the exosphere. This is the widest layer of our air bubble. Scientists believe its boundaries are about halfway to the moon at 120,000 miles. This is the point where the pressure of solar radiation begins to exceed the Earth's gravity. It's still part of our atmosphere. This means that astronauts who went on various space missions and have been on the ISS have actually never left the Earth's atmosphere.
Attention! Attention! Residents of all countries and cities of the world! A massive asteroid is approaching the Earth! Now its speed is several times greater than the speed of sound, and each day it accelerates even more. Once it enters our solar system, it will fly past Uranus, Saturn, Jupiter, and Mars. The gravitational fields of these planets will also accelerate the asteroid, and our planet will be the final destination. A collision is inevitable. According to scientists, a meteorite the size of Mount Everest can destroy the entire planet. The disaster will happen in 350 days. There's panic in the streets. People buy and build bunkers. Scientists and astronomers from all over the world were assembled to find a solution. The only way to avoid the collision is to destroy the space object. Yeah, a powerful rocket can split an asteroid into hundreds of thousands of pieces. In this case, a meteor shower will hit the Earth, but it's better than the complete destruction of our home. In less than a year, people build several powerful rockets. Then, using the best telescopes in the world, Astronomers create a unique guidance system. And now, we just have to wait for the asteroid to get into our solar system. All the people start moving to one continent with top-notch bunkers for everyone. The damage from the asteroid is impossible to predict, so it's better to hide people in one super large safe place to wait out the collision. The moment has come. The asteroid passes by Uranus. The speed increases. Now the colossal space object moves only 10 times slower than the speed of light. Scientists launch rockets into the air. The asteroid flies past Saturn and destroys a part of its ring. The asteroid's trajectory is changing. It flies past other planets through a twisting path, picks up speed, and now heads towards the Earth. The rockets leave a long trail of fire behind and reach the speed of sound. They're getting closer to the asteroid. Near Mars, a collision happens. The rockets hit the target. The asteroid explodes and splits into millions of particles. All the pieces fly in different directions. The Earth is saved. At this moment, the Earth's satellites record a huge burst of energy. A small part of the asteroid is headed towards Earth. It's tiny, about the size of a grain of sand. But the explosion accelerated it, and now the grain of sand is flying towards the Earth at a speed of 185,000 miles per second, which is 99% of the speed of light. At this speed, the grain has almost the same destructive power that the entire asteroid had. It's approaching the moon. A few more seconds, and the grain of sand will hit our planet. All the people are waiting with bated breath. The grain gets such incredible power because of the laws of physics. The greater the speed any object is, the more mass and energy it has. When the grain of sand reaches a speed close to the speed of light, its energy and mass begin to increase dramatically. You can't even see this tiny grain of sand, but inside, it has the mass of an entire continent. If the grain reaches the speed of light, its mass will be infinite, and then a black hole will appear. In this case, all living and even inanimate things on the planet will disappear. Trees, seas, and oceans, all the cities, countries, and continents, air, sound, atmosphere, any molecule of the Earth, everything will be absorbed by the incredible gravitational force of the black hole. Then, when there is no trace of our planet, the hole will take over the moon. The gravitational force will grow and absorb other planets of the solar system. Soon, it will reach the sun. Our star will split into thousands of strips like spaghetti and will emit a tremendous amount of energy. This could trigger the birth of a second black hole, but fortunately, we only have 99% of the speed of light, which changes everything. Also, no object that has mass can reach the speed of light. The grain of sand enters the Earth's atmosphere. From the outside, it looks like a blinding meteor that pierces the sky. The grain heats up, passing through the layers of the atmosphere. Clouds within a radius of 100 miles around are burning up. The sky becomes crystal clear. If you look at it in slow motion, you can see the air is ionized because the air molecules are split. In nature, this process occurs during lightning flashes. Our sun also has ionizing energy and disinfects the air. The meteorite leaves an ozone hole behind it. So now, this place is not protected from space radiation and ultraviolet light. The grain of sand flies straight into the center of the Southern Ocean. The closest continent to the explosion is Antarctica. The air around it warms up and mixes with the cold temperature of the ocean, creating hurricanes. As soon as the grain approaches the ocean surface, the water starts boiling. The temperature and energy of the grain are so huge that the water evaporates, but the vapor molecules are instantly burned up. Thousands of gallons of water just disappeared from the face of the Earth. The grain flies down for the first few feet without touching the surface as the water evaporates before it. Then it falls into the ocean and creates a powerful explosion. Hundreds of millions of gallons of water foam and boil because of the hot temperature. The entire ocean within a radius of 100 miles is illuminated with a bright light. The ocean depths, where sunbeams have never been before, are almost as transparent as the water at the bottom of a pool. The wreckage of old sunken ships splits into atoms because of the powerful explosion. Unknown sea monsters and giant squids that live in the dark are afraid of the bright light and swim away. Then, finally, a grain of sand touches the seafloor and penetrates deep into the Earth's crust. If it reaches the Earth's core, the planet will most likely explode from a burst of incredible energy. Fortunately, this is not going to happen. The resistance of the ocean and the ground slows down the grain and takes its energy away. It provokes a slight shift of tectonic plates, and there's more to come. Huge waves form and spread throughout the ocean. The blast wave creates enormous tsunamis. Imagine throwing a small rock into a puddle. The same thing happens to the ocean. Huge waves are approaching the coastal cities. Fortunately, people were evacuated from there, but the damage caused by one grain of sand will cost hundreds of trillions of dollars. Houses are destroyed, roads are flooded. After a while, it starts raining with hurricanes. Ocean water vaporized by the grain forms into huge storm clouds. The wind drives them to the continents. And then, after the tsunami, prolonged rain begins, flooding entire countries. Several days later, natural disasters are still here. The temperature of the Southern Ocean has increased by several degrees. The water is boiling at the collision site, melting the Antarctica glaciers. Millions of icebergs are melting away, so the water level of the world's oceans is rising. The edges of some continents go underwater forever. Thunderclouds reach the Sahara and other deserts. The shift of tectonic plates causes earthquakes on some continents. Volcanoes are awakening. The sky is filled with volcanic ash. It will take months for all the ashes to settle. In the beginning, it creates challenging conditions for life on Earth. Plants and all living things don't receive enough sunlight. In trees and seaweed, photosynthesis is disrupted. Oxygen production stops. It's getting harder to breathe. The air that has filled the planet's atmosphere is slowly running out. People have to adapt to new conditions. They build new cities both on the land and in the ocean. They create plantations with artificial lighting for photosynthesis production. Fortunately, all the problems end when the ash settles. Inside the volcanoes, there's hot magma flowing. It may come in handy as it's rich in chemical elements and minerals. Together with the ash, nutrients fall to the ground, and the soil is now well fertilized. Plants, trees, fruits, and vegetables grow incredibly fast and produce a lot of new oxygen. The Sahara is filled with blooming flowers now, and it looks more like a meadow with flowers, not a desert. The grain of sand just renewed the planet instead of destroying it.
Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink seawater. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams live long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps. Each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet.
The Earth has 3 main layers: 2 parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon. And made of nickel and solid iron, it's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which in turn protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the Sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.